much. So the topic for today is to kind of think about like how we can build applications with GenAI, and that it may require certain data structures and technology. But before we go there, I want to give you some context about me, who I am, what I'm doing. So I always enjoy taking data, taking some compute, and try to create a better life. Not necessarily for me. I'm very customer focused on my users, what I can do for users, and good user experiences. But I've always worked in an enterprise context, right? So this has been about like making money, you can say, right? Let's use that ugly word. So I think it's important to kind of have that context. So I'm going to try to take you to a tour. I know I have 20 minutes. I know we're at the MLOps meetup. This is my brain dump that I did when I spoke to my colleague about like this event. I assume some of you are new to Neo4j and new to graph technology, so I'm kind of try to address that, try to make the content suitable for you. RAG and tools and agentic frameworks is like, yeah, a hot topic today. It almost sucks the air out of every conversation. So I'm going to kind of address that a little bit, and then also going to try to kind of explain what Neo4j is, why you should care, when you should use it, or when you should care about it. And I already talked about enterprise. I come from like enterprise stuff. So the subtitle that I didn't fill in on the first slide was like, yeah, you need an intuitive and flexible data model and a powerful query language for connected data. That's a bold claim. I don't know if I stole that from someone or if it's my claim. There are going to be bits and pieces here that are like what I have to say because I work for Neo4j, and then there are going to be some personal opinions throughout this presentation. So the emojis are definitely my personal opinions. And it's an evolution question mark. Like, so we all know that these LLMs have been along for a long time. They become very kind of popular when ChatGPT started. I think they're shit in its basic raw form. Like, they are not a component you can use on its own, because they have drawbacks. Like they struggle with math and reasoning. They also they can have built-in biases because of the data it was trained on, and they kind of complete sentences and answer any type of question. So they don't reason. They don't give you facts necessarily. Right? It's more a coincidence if something you get back from an LM is actually factually correct. Technology-wise, you don't need that much. A bit of prompt engineering, an API call away. You need, if you run these models on your own, you need a bit of hardware, right? The next thing I'm just laughing at is it's ridiculous. RAG, right? So people started building RAG, retrieval augmented generation systems, to retrieve their own facts and try to kind of give that as a context to the LLM to generate an answer. But that came with some challenges as well. I think data quality. I don't know how many times we've tried to build a graph with an enterprise and they say, well, yeah, our data is so great. And then it's like, turns out that their data is shit, right? Data quality is an issue. Scalability, both in size and complexity, becomes an issue. It's not always easy to retrieve what's relevant to a question and find the right context. Technology-wise, like, yeah, semantic search or vector databases, vector indices became a thing. Some combine that with full text queries to just get a combination of like searching for terms and semantic similar things. Or generating queries or using query templates to kind of retrieve data. You see at the bottom note here, like, I'm not going to comment on copilots, note takers, vibe coding, that type of things, because, yeah, it doesn't really have a home in my enterprise heart at the moment. So I have no feelings about that yet. Maybe Willem will change my mind a little bit. And then, yeah, cool stuff, tools, like arming your LM with tools that it can invoke and use. has some challenges. It can get out of control and complex to handle a lot of tools. And you definitely need to start thinking about how to orchestrate all those tools. Maybe plug in features so you can do internet search for like public facts, as well as calling functions that, performs tasks or pick up specific like data points from your corporate facts. So that's pretty cool, I think. And I guess today we're in this like new agentic world. Sorry. And I didn't find an emoji for that. I'm a little bit like, I don't know if I should be like happy about it, if it's just like too much, or so it remains to be seen a little bit. I think the challenge is like transparency in decision making. Like once you start introduce these like higher level agents that do a bit of planning and come up with strategies for how to call different APIs, or if you have MCP servers and all over the place, right? You do run into some like transparency issues and governance issues. So you need even more tools now. You need to know how to build a good planning agent. You maybe need to give it procedural memory or different types of memories to here and there. Evaluating is becoming a big topic. Testing, I guess, but since it's AI, we need to have another word for it. So evaluation and governance. So I think overall, like, we still have all these like challenges that we're trying to overcome, and we just keep stacking up like more and more technical elements or kind of things we have to implement to kind of use this. So that's just a little bit my personal perspective on like where we are, and maybe I should go back. A lot of these things like function calls, memory and stuff like that, it requires data to be persisted or data to be retrieved, and finding relevant context is all about like how efficiently can you query and kind of can you work with evolving models and schema and stuff. So that brings us into what is Neo4j, why should you care, when should you use it. I'm going to try to, this is the only marketing slide I have. So I'm going to try to do it very kind of like back to roots, basics. So in Neo4j, we have a data model that we call label property graph. So that's how we think we should represent data instead of tables or columns or documents. So we have nodes representing entities, and we give them a label so we kind of can figure out what type of entity it is. So that's the label part of the graph. Then we have relationships that kind of are there to say like why are two entities related, assembled together, connected for some reason. And we try to give those semantically meaningful descriptions. And then we have properties, which is key value pairs of different value types that just to store additional information about the objects or entities and the relationships. So the idea here is to have like a flexible data model where you can expand as you go along if you're kind of working in iterations, where you constrain the model as it is kind of optional. You can constrain it if you want to, but you can also kind of add whatever you like to your graph. The idea is also that you should have something which has low overhead in terms of cognitive load. Usually this, like you think about like real world objects, and they got a little bit like messed up when you do normalization and stick them into tables. We like to think that this is like, just model your graph like you would kind of reason about or talk about the real world, like persons living together or owning or driving a car. It also allows you to find new insights and connections. And we have the kind of the concept of a database, right? Neo4j is a graph database. We call it a graph database because the model we saw is like how we kind of push data in and out of the graph or of the database. And the storage engine is optimized for traversing the graph, right? So it is like an ACID compliant database that allows you to kind of, store and retrieve data, push down complex queries to the database. And this is funny because the last bullet here that you see on the slide, adding context to AI systems, I think that bullet and the slide is probably 7 years old. So it's always been a thing that, when you want to build some intelligent solution or train a model or do some advanced decisions, what kind of falls into AI, you need context about your objects, right? You can't only look at the discrete object. You need to understand the situation it's in, and that's usually where kind of you start kind of figuring out what's the position in the graph, how it's connected to other things. And then query. Yeah, we need to be able to query a graph. We could have used SQL, but we introduced our own query language that is now partially like compliant with a standard that's called GQL. So the idea behind this query language is to kind of relieve you from thinking about complex joins and think about like patterns in your data instead, or like shapes of data, or how things are connected. So this very, very silly, simple query, you can read it from the back, where you have a product category with the name 5G products, and then in front of that you have something like categories that rolls it up into parent categories, and the 1 to 3 just means like 1 to 3 times. So you're going through like a categorization hierarchy with unknown depths, and then looking for any product that rolls up into 5G products. It's a one-liner. I did a two-liner because we usually put the return clause on its own line. In SQL, I began to write the query. This is exactly 3 levels deep, but if I want variable depth, I would have to it beats my SQL skills, to be honest. I would have to kind of think about like how I recursively call a function instead or something. Graphs are also quite useful in analytics. So there's a ton of algorithms that are taking a graph as an input and outputting some value or a new graph. So one set of algorithms is, for instance, centrality algorithms. So you can think about like if your graph is a computer network, what would a central node mean? It could mean like where you need capacity. It could be a choke point. It could be a good point where it's easy to reach all other points, so it's a good place to distribute information from, and so forth. If it's a kind of a supply network or a supply chain, I mean, it could be where you should have stock in parts, or it could be like a sensitive point in your supply network where, if we have failure here or interruption here, then production stops. Another set of category of algorithms is pathfinding algorithms. Maybe the most obvious graph algorithms, finding different paths or routes throughout the graph. Again, depending on what network you have, these algorithms could yield different answers. Like, again, a computer network, it could be like, this is really a best way of finding maximum capacity throughout the network. If it's a transportation network, it could be like, let's not optimize for the shortest path. Let's optimize for emissions or some other weight on the path, and so forth. So that's a little bit what Neo4j is. It's like a database with analytical capabilities and query capabilities. When should you use it? I think like this is a little bit like how I view the world, as very connected. We have these objects that we deal with on a daily basis, and they're becoming increasingly more connected, right? And as a customer or as a user of any service or product, you expect those things to work, right? We're starting to take things for granted that you when you search for something on your phone and then go work on your computer, like it pops up there what you just searched for. If you're buying a product and it was recommended by someone, you expect that that recommendation is faithful to the product. So we do have these like connections, and everything is becoming more connected. And usually when you walk inside an enterprise, you have these silos of data where you have This is where we do sales. It's our CRM system. This is where we deal with fulfilling orders. We have our ERP system. Here's where we deal with some other kind of how we bill and invoice and charge our customers. And you have all these data silos. So I think of it as like, what happens to our data or the representation of the real world is that we have some kind of model loss where we kind of just spread that data across the enterprise. So I think one use case for a graph is to just reconstruct that reality from all the data sources you have. Try to kind of connect across silos, bridge silos, take data from different domains. You get a complete picture, more end-to-end picture from like supply to demand being met. Another use case or application or good situation would be if you're doing a greenfield application and you know that, my domain is going to be extremely interconnected and it's going to have high value for me to kind of understand the context and finding paths and traversing through the graph to kind of understand where in the network is this node and what does it mean, right? So to the point, what does it mean for typical GenAI use cases? Well, we see a lot of customers doing the graph on the left-hand side, like a lexical graph where they start with some unstructured data that they typically have in a document, and they chunk it up and then extract entities and the relationship between the entities, and then you're left with like something which is like has a bit of entity resolution problem. So you typically try to group that together and do entity resolution and kind of get a high quality, high fidelity picture of what information was in that document. And then you run through hundreds of thousands of documents and you end up with like a knowledge graph representing the entire knowledge in those documents. And that becomes like something that where you can kind of use all these like different strategies. You can build tools on top of it. You can go in and do a semantic search using our vector index. You can use full text search. And then you have also various ways of like saying, okay, but what's one hop away or two hop away? What context did this entity appear in? And you always have full traceability back to the source document. What we also see that a lot of customers already have their graphs. So they have a domain graph. I don't know what's this. Oh, the traditional movie graph. How boring. But that's also like, the same principle applies there. If you want to kind of, you typically have that graph because you already realized that, okay, we can do really powerful queries that answer important business questions. Let's just slap a tool on it now and build some agent that, or some MCP server that agents can interact with. To give an example, here's just a silly toy example, a tool that, given the full name of a person or a legal entity, would retrieve information about like if you hold any shares or are invested in any way. So you can see like just a basic query there, matching the officer is the label for persons in this graph, and then just collecting context, right? Who else is registered on the same address? Or I could have added here like, or if you live together with someone or is married to someone. So I try to kind of just collect a little bit more context than the person in focus. And then I also collect like, what shares is the person holding, others close in proximity to him, what shares are they holding, and return the same. Right, so I ran that through an example. So I asked the question like, what shares does Sigmundur David Gunnlaugsson hold? He used to be the Icelandic prime minister, if anyone is remember that. So you can see like what happens throughout the chain, like they picks the correct tool with the right name argument, and you can see the response from the tool. You get like, that David or Sigmundur held some shares up until December in 2009 in Winters Inc. And then Anna started holding shares on the same date, and she had some shares from before there, 2 years before as well. And you can also see that, they live together, right? And you can see the final answer from when we kind of feed the data and the question and kind of generate the response that, Sigmundur held shares in Winters Inc. from 2007 to 2009, and his associated person who lives on the same address, who is actually his wife, holds shares from the same starting date and continues to hold them. You can also look this up on Wikipedia, right? What happened to and the news coverage around this, where they tell exactly that story, that he actually sold those shares to his wife prior to new legislation taking place that would force him to reveal his conflict of interest, right? So I think another way of I want to leave you with some thoughts here. Data comes in many different shapes. You maybe don't always think about it as like graphs and these circles and arrows, but I do think anyone has come across the data feels complex to some degree, or that it's that you have deep recursive hierarchies. You may have come across where you start to see patterns emerge if you just compare the connections a little bit. So you have this kind of inference that these two are probably also connected. You may have deep hierarchies. So these are typically kind of situations where most people just fold. They just no, this is hard, so I'm going to ignore it. I think that's where Neo4j comes in, when you have those type of situations where you feel like the data is really hard to work with for my tools. And I think we should not give up there, because it turns out those are the situations where we usually do innovation, where we kind of create a better service, a better product. We change the experience of a user. We improve our processes. We improve security or employee satisfaction. So I just brought this as an example of regardless of what you're doing as a business, even if you're a smaller business, you don't have to be an enterprise. You probably have employees, you have suppliers, you have some product, you have customers hopefully buying your product or service, and they transact with you. Hopefully you're not giving all your product away. And you have processes and you have security and that stuff. And inside each domain, there are interesting graph use cases, but also across these domains. Once you start to connect your supply with product and customer demand, right? That's when you can come up with really dynamic pricing, or unfortunately hotels do this. So when there's a big event here in Stockholm, prices just spike, and it's 3 times as expensive to stay the night here. I just want to leave you with a query as well, right? Some queries can be simple. I show the product's roles into a product hierarchy. This is slightly more complex query, but it looks compact and nice, I think. So you can read it from the end, kind of that you have a transaction of interest with a specific ID that someone has performed. And before that, you have this 1 to 3, which is saying how frequently a pattern repeats. And inside there, you have a pattern where you have some node performing a transaction to some other node that performs a transaction to another node. And these two transactions needs to be ordered chronologically. So basically this query would say in chronological order, how is money flowing into this account before it's transferred somewhere? So this could be a check you do, right? Just to see, is this a normal transfer? So if I was sending money to my kids, it would be the money came from hopefully Neo4j if I behave at work, if they still have me after this presentation. And my usual transaction pattern is send the kids money, pay the bills. But if it comes back like this, that's probably something that's suspicious, right? The highlighted transaction with an extra circle around it is the transaction in focus, and you can see that money has been coming from a lot of people in many steps flowing towards this account, right? So this would be your typical, small drug operation where you kind of money flows towards a kingpin or someone in charge. So I want to leave you with a thought of trying to write that in SQL, right? And if someone completes that before I complete my beer after this presentation, then come to me and we'll test it and run it and see if it's faster. That's all I had. There is a ton of useful resources about Neo4j online, from anything from like learning fundamentals about graphs, how to model your data as a graph, how to kind of learn how to this wonderful query language. But I mean, we have this like culture at Neo4j where we really value relationships, and we don't want to let our users down. So my saying is like, don't suffer in silence. Adopting and putting new technologies to use is not always easy. And if you want some guidance and help, then me and my friends at Neo4j are here for you. So thank you very much.
Thank you so much, Håkan. Excellent presentation, really interesting. I'm now very